Hello and welcome. You are looking at parallel and perpendicular lines example problems. Alright, we have some lines here. Now these lines are not necessarily parallel. They could be, though they don't look like it. And you have one line going through all of them. That is called a transversal. That's line S. And then there are some angles, and they do still have, there are pairs that still have relationships, even if they aren't congruent or supplementary, even if the lines aren't parallel. They still go by those names. So angles 5 and 8, so what I'm going to do is I'm going to go ahead and change the color here of my lines when I show you them. Angles 5 and 8, what I want you to find is the line that shares angles 5 and 8, in which case most often it's just going to be the transversal we're referring to, that one, and then the angles, and then the lines that form the angles. So there's 5, there's 8 right there, and then you can more clearly see what it is we're looking at there. So for instance, this is the only time I'll do this. But that's the kind of relationship right here. Here's 5 and here's 8. What kinds of angles are they to each other? So initially, right off the bat, you might not see it. But here, you can see that they are, let me get rid of those now. Those are alternate interior angles. Now, in this case, if the lines are not parallel, they are not congruent. But that does not mean they are not alternate interior angles. All right, 6 and 2. Let's start with the transversal. I'm sorry. Let me keep the transversal up there. Here's 6. Here's 2. What kinds? Here's 2 and 6. Those are corresponding angles. Kind of go in the same direction. I don't really know the best definition to say because when they're not parallel, they're not always looking like they're going the same direction, but it's pretty close enough. They're on the same side of the transversal. One's on the inside, one's on the outside. Okay, 2 and 7. Whoops. Let's see here. Well, that was 2. Let's keep that up. 7 is 7's up there. So there's 2, there's 7. You don't even need another line to do that. These are called vertical angles. Now, vertical angles are always congruent. You don't need parallel lines for it, and like I said, you don't even need a second line for it. You need 2 lines, but not 2 lines with a transversal. 1 line and the other give you 2 and 7. Those are congruent. Okay, 3 and 12. Let's find those guys. 3, 12. Like I said, the transversal is still the same. Here's 3, here's 12. Those are on opposite sides, so alternate. They are on the outside, so they're exterior angles. 9 and 12, well, same 2 lines with the transversal. Here's 9, here's 12. They're on the same side of the transversal, and they're on the outside. Now again, keep in mind, this is why I drew these lines, because you might look at 9 and say, that's not on the outside, there's this line right here. Yeah, but we're not referring to that line at all. We're only referring to the ones that make the relationship. So if you hide this completely, 9 is on the outside here, and so is 12. Those are same side interior angles. And then finally, you have 10 and 11, which again, with the same 2 lines in the transversal, here's 10, here's 11. Now these are on the inside, so these are, oh, I'm sorry, I wrote interior here. These are exterior. 10 and 11, same side on the inside. They are same side interior angles. My fault for what I wrote before. Now let me just add one. What about angles 2 and 8, for instance? I want you to know what those two are called. When they're adjacent and they make a straight angle, that's called a linear pair. So they are a linear pair. They're supplementary. They add up to 180. They make a straight angle. They're adjacent. I just want to make sure, in case I use that term, that's what I'm referring to, linear pair. Okay, number 2, calculate the value of x. Show your work for full credit. So what I'm going to do again is sometimes you might not be able to recognize what it is you're looking at unless you can hide other lines or extend other lines, etc. So this first example here, they give these arrows to indicate that these 2 lines are parallel. So what I'm going to do is extend these lines all out just a little bit more to give you that relationship a little bit more easily. You can now see These are two lines cut through by a transversal. These are alternate interior angles. And when lines are parallel, then alternate interior angles are congruent. Therefore, the measure of this angle is equal to the measure of this angle right here. And you use algebra to solve the rest of it here. You'll get x equals 8. I subtracted 2x to this side, subtracted 17 to this side. And x equals 8. Now, it does not ask for you to find the angle measure, but if you plugged either of them in, you'd get the same angle measure because they are congruent. Okay, second example here. Let's choose different line color. Here are my two parallel lines. This arrow got kind of messed up over here. But these two lines are the parallel ones. And then what you want to find is the transversal that has both of your angles in it. So this would not be the example of your transversal. It would be this one. Here's the transversal with the two parallel lines cut by it. These two are now same side interior angles. And when lines are parallel, same side interior angles are supplementary. So what I'll do is add these up, and I'm going to get 180 degrees when I add them up. X plus x is 2x. 20 minus 40 is negative 20. You add 20 to both sides, you're going to get 2x equals 200. Divide by 2, you'll get x equals 100. And again, if you plug it in here, it looks like this would be 120, and this would be 60. And those indeed add up to 180. Okay, this third one, especially more confusing looking. Let's go ahead and find first the transversal that divides our sets of angles. So here's a known angle. Here's, it's an unknown angle, but here's an angle measure. Here's a known angle measure. Here's an unknown angle measure. It looks like this line is the transversal because it's the one that cuts through all of your different lines. Now, you might say something like, this line might be crucial for something. It won't really be. You'll see why, because these two aren't a special relationship. This is not a linear pair, for example. This is not a relationship where I can use an equation to know something about them. But if I add these two angles up right here, there might be something that's interesting about that. So if that's the case, what are the other parallel lines? Well, these are the parallel lines, but I mean, what are the other lines that make the angles? And it's these two right here. So it's this one that's being ignored. If you can hide that out of your way, and if you can treat this as one large angle, remember the angle addition postulate, if I add those two angles together, I'm going to get the measure of the entire thing. So what's that angle measure with this angle measure right here? What's their relationship? Well, if you tilt your head a little bit, take a look. They're on the same side of the transversal, and they're on the outside of your parallel lines. These are called same side exterior, this time I said it right, angles. But just like same side interior angles, when you add them up, you get 180 degrees. So notice I did 45 plus x. 45 plus x makes the entire angle right there, and that helps us solve for x in the end. Combine like terms, 2x plus x is 3x. Negative 30 plus 45 is 15. So 3x equals 165. And x, I think that's 55. If I'm wrong, I think I'll notice that pretty soon here. And again, you can double check your work and make sure that they add up to 180 when you do it. Okay, number 3, circle the correct answer below. Show work for full credit. So they're giving you that P and Q are parallel. And if you have those diagrams, why don't you go ahead and draw arrows on them that represent that they are parallel. M and N are parallel. I'll do arrows here again, but some I'll use 2 to differentiate what I'm looking at here. And measure of angle 2 is 105 degrees. So once again, this is something where I could just take away that angle 2 and make it 105. We have to find the measure of angle 1. So the way to do this is some sort of set of angle relationships. There are a bunch of ways I could do this. I'll give you just a few, and then you could probably work from there. But what you have to do is not just say, well, this is what it looks like. You have to go by the sets of parallel lines and go from there. So for instance, if this is 105, because these two lines are parallel by the corresponding angles postulate, this is also 105. In a way, what I'm saying is also is kind of like a proof, right, by the corresponding angles postulate. Now, because these two lines are parallel by the same side exterior angles theorem, angles 1 and 105 are supplementary. So I could say that measure of angle 1 plus 105 equals 180 degrees. Subtract 105, you get measure of angle 1 equals 75 degrees. So 75 is your answer. That's only one way to go about it. What I could have also done was said that these two make a linear pair right here. So this has to be 75. And 75 and 1, because these two lines are parallel right here, these are corresponding angles, and by that postulate, these are the same. I could have also done things with this being a linear pair, these being same side exterior angles, everything like that, and these being corresponding angles, all because these lines are parallel, but you have to know that the lines are parallel before you can say anything like that. And I can't just jump straight from here to here because there's no one transversal that these two angles are being formed by. So there's a little bit of lead-in to make it happen, and because it's multiple choice, maybe sometimes answers can trick you. For instance, this 105 is also here. You might assume it's one of those. But normally when lines are parallel, you're either looking at something congruent to it or something supplementary to it. These other two would have very little to do with it, unless your math is incorrect or unless you're looking at an angle that's divided in some way. Okay, number 4, calculate the values of x in the diagrams below. Show work for full credit. So the first thing that I'm going to note here is that this is a right angle. I want to make sure that we know that this whole thing's 90 degrees. That being said, there are a lot of different ways we can go about this problem as well, but let me just go through 2 of them. The triangle angle sum theorem says that if I add up all of the interior angles of my 3-sided polygon, otherwise known as a triangle, I get 180 degrees. So if I call this angle here y, that if I add 34 with 84 with y, I'm going to get 180. I was trying to add these up instead. And here, this will be 118. Subtract 118, you'll get y equals 62. So if this is 62 degrees, now what I want to look at is the bigger triangle, the right triangle. Right here. Where is it? Let's see, right here. This bigger triangle is a right triangle. This is a 90-degree angle right here. So if this is 90 degrees, you could say that 90 plus 62 plus x is 180. But in a right triangle, if this one is 90, then these two angles are complementary to each other. Complementary, not supplementary. It means that when you add up these two angles, you're going to get 90 degrees. Because this is the last 90 that makes up the 180 of the triangle. So you don't have to write that extra 90 in if you don't want to. So x is 28. So x is 28 degrees, and that'd be your final answer. That's one way to do this problem. A second way to do this problem, move this stuff out of the way here. Second way to do this problem is to focus on this triangle right here. Hang on. Focus on the smaller triangle right here. And you can get the other two angle measures first because this is a linear pair. See, I knew I'd say that word. So 84 plus 180, or plus y, I'll call that y, equals 180. So this value, I guess, is 96. So y is 96 degrees. These two are complementary because this makes a right angle. 34 plus z equals 90. So this one's 56. So now you can add up these three to get 180. 56 plus 96 plus x equals 180. And you'll get the same stuff here. 56 plus 96 is 152, where x now equals 28. So those are two different ways to solve that problem there. And there might be more, but those are the most convenient for me. Let me erase that work. All right, part B. Like I said, in a triangle, all three angles add up to 180 degrees. So 5x plus 4x plus 5x plus 12 equals 180. 5x plus 4x plus 5x is 14x, and here's that 12 once again. When I subtract 12 to the other side, I get 168, and when you divide by 14, I think that's 12. 140, yeah, I think that's 12. So x is 12, and it doesn't ask you to find the angle measures, but again, double checking measures are always good. Okay, part C. Here you have an exterior angle x. Now, if you really wanted, you could say that this is 180 minus x, because x plus this value should be 180 total. And then you could add these three up to get 180. But if you know the exterior angle sum theorem, or if the exterior angle theorem for triangles when you're working on their sum, if you add up these two remote or non-adjacent interior angles, you'll get the measure of this exterior angle without having to do the extra work of adding a 180, then subtracting 180 again. So if you just do 66 plus 42, you're going to get x. Because remember, 66 plus 42 plus this value is 180. And when you subtract this value from 180, then you'll get this value. So again, you're adding and subtracting twice. So this is 108. Okay. And then the last one here to solve for x, what would be nice again is this is once again an exterior angle. So if I had this angle measure and this angle measure and I added them up, then I'd get the value of x. So this angle measure is a part of this linear pair with 137. So 180 minus 137 equals 43. And 43 plus 75 will equal x, which is 118 degrees. Should probably put degrees for all these. And that was 28 over here. And that's it for D. Okay, what are the measures of one exterior angle and one interior angle of a regular 15-gon? Let's see if I even have a 15-gon shape on here. I do, so check this out. So here's a regular 15-gon. Regular meaning all sides and angles are congruent. So you just need one exterior angle here. Now here are the different exterior angles. You extend one of your sides out. The angle that's formed by the actual side and the side extended, these guys right here, are your exterior angles. And like I said, in a regular polygon, if all interior angles are congruent, then all exterior angles are also congruent. So there are two ways to go about it. One way is much easier than the other. Let me go by the harder way first. That way you're well aware of it. And then I can probably speed up time the next time we go over it. I could find the measure, the degree of the interior angle sum. The interior, I said, angle sum of this 15-gon. That'll be 180 times the number of sides, 15, minus 2. It's a formula that basically says that if you have that many triangles built in this polygon, then that's the number, that's the measure of the interior angles of the polygon by the triangles. So 180 times 13. Let me go to the calculator for this to possibly save time here. This number is 2,340. Now that's the interior angle sum. So when I add up all of these inside angles, I'm getting 2,340. Because it's a regular polygon, each interior angle measure could be divided by the number of sides or angles there are, and then you'll get the measure of each individual angle, which is 156. I'll say over n, over the number of sides, 156 degrees. So each of these is 156. Now, if that's 156 for an interior angle measure, an exterior angle measure makes a linear pair. Notice how much I've been using the word? It's a good thing I talked about it. Notice that this is a linear pair with this one because I extended a side and these two add up to 180. So an exterior angle measure, just one of them individually, is 180 minus 156. That's 24. So each individual one is 24 degrees. Oh, you do need one interior angle. I don't even know why I said that. Well, anyway, this is the longer way to go about this problem, now that I've said all that. Not significantly longer, but longer explanation for sure. The shorter way of doing this, let's see. So here's the answer. I'm sorry, I didn't notice the interior part. The shorter way of doing this is to find the exterior angle measure first. Because one theorem about exterior angle sums is that when you add up all of these exterior angles in any polygon, doesn't even have to be regular, but in any polygon, it is going to be 360 degrees. Regardless, doesn't even matter. Now, to find the measure of one exterior angle measure, you, of course, divide by 15, the number of sides. And that will give you 24. So then you find 24, and then you find this one by subtracting 180. You do 180 minus 24, and you'll get 156. And so, like I said, there are two different ways to go about that problem. I just did significantly harder way, and then I did what I think is the easier way there, and that's both of them. Number 6, given the graph at right, write an equation of a line that is parallel and one that is perpendicular to the given line passing through A. Parallel, perpendicular. All right, so a couple things we need to note here. Let's figure out the slope of this line by figuring out distinct points that it's crossing through, such as these two. I just need to find out how much it falls and how much it runs. So remember, since it's falling, as it's going to the right, the slope will be negative. This goes down 2 and over 3. So my slope of this original line here is negative 2/3. Now, I don't need to know the full equation, so I'm going to create my own. But if you want it, this equation is y equals negative 2/3 x minus 1. That minus 1 is coming from the y-intercept there. But this will be very, very irrelevant to what we're doing. We just need to make sure that our answer doesn't have the same y-intercept if we're talking about parallel lines. So if we're referring to the parallel line through A, then we know that our slope that we're going to refer to is negative 2/3. It needs to be the same as the other one. So there are a couple ways to go about this problem. I'll go through both, and then through perpendicular I'll just do one way. Because you're not even going to see where this y-intercept it's going through, as it looks like. So there are two ways. There's slope-intercept form and there's point-slope form, and either way will get you to the same answer. So here's slope-intercept form, y equals mx plus b, and point-slope form looks like this, y minus y1 equals m times x minus x1. Maybe more confusing to memorize, but a lot easier when you're dealing with a fraction such as this one right here. All right, so let's look at point A here. This point is negative 1, 3, and what we need to make is a line that's parallel through it. So this green one's right here, and the blue one will be the one that's parallel to it. So this won't be perfect, but if I'm going, well, it might be going down 2 over 3 like that. So what we're trying to find is the, there we go. What we're trying to find is the equation. So I'm going to start with point-slope form to kind of see why it's easier. First of all, if I substitute, this is x1 and this is y1. If I substitute these 2 points into that equation, that'll be y minus y1 equals m times x minus x1. So minus negative 1 is plus 1. And that's it. Your answer's done. You can leave it in this form, and that's entirely okay. Sometimes when it comes to asking you to graph something from this form, maybe you forget that, like this says negative 3, but the value is actually 3, right? And this is positive 1, but the value is actually negative 1. Maybe if you're graphing, you forget to do the opposite here. But once you have that point, you just use the slope afterward, and it's just like slope-intercept form. Now, as you can tell, the reason why I want to emphasize that one is because if I do slope-intercept form, then I'm going to be looking at a fraction y-intercept value, which means you'll have to deal with fractions. So I'll do it for you once, and I'll show you 2 different ways to do it. One way is to start in this form. If I add that 3 over to both sides, and if I distribute the negative 2/3 into the x and the positive 1, I'm going to get negative 2/3 x minus 2/3 plus 3. Now, as you can tell, I have to combine like terms here, negative 2/3 and 3. So I'm going to rewrite 3 instead as a fraction over 3. That's 9/3. Now you have to do negative 2 plus 9, and that's 7. So y equals negative 2/3 x plus 7/3. And that would be the answer, another appropriate or equivalent answer to this one right here. They're both the same answer. They both refer to the same graph. This one might have been more confusing to memorize, but this one deals with fractions. So it's really up in the air how you want to do it. There's a third way to do, or there's a second way to do this way right here, and I'm going to go ahead and do that for you, is if you start off in y equals mx plus b form, let me give myself, I'm just going to write over here and move it over in a second. If we're doing y equals mx plus b form and I already know the slope, now we need to find, of course, y-intercept. So let's choose a point that we know, such as negative 1, 3. Be careful, substitute 3 for y, not for x. And then negative 1 for x. So 3 equals 2/3 plus b, and you're going to subtract 2/3 from both sides. So you're going to do b equals 3 minus 2/3, and once again, you have to work with fractions. 9/3 minus 2/3, which is 7/3. Once you have 7/3, you would then plug it into your mx plus b formula, and you'd get there again. Lots of different ways to do it, but this one's the most, I guess, turn off your brain-ish as long as you know the form. These other ones here are decent alternatives. In fact, for me, the last one I stated is the one that I normally do personally. But but I'm okay with fractions. And I'm not saying that you guys aren't as you try and do these problems. I'm saying that go with what's most convenient for you and that makes most sense and that you're comfortable doing, really. I'm going to move this stuff over. That's okay. The arrow's still pointing to something that makes sense with it. All right, let's go ahead and do the one that's perpendicular through this point right here. So it has to be perpendicular to this line, but if it's perpendicular to this line, then it's also perpendicular to this one. If you know your theorem, a line that's perpendicular to one of two parallel lines is also perpendicular to the other. So it doesn't really matter. It's perpendicular through both because they have the same slope. And if they have the same slope, then what is the slope of the perpendicular line? Well, if the original one was negative 2/3, this one will be the opposite reciprocal, positive 3/2. I change the sign and flip the numerator and denominator. So up 3 over 2, up 3 over 2 would give you, like for instance this right here. If I started here, up 3 over 2, boom, up 3 over 2, etc., will give you a perpendicular line. Now I know that you're looking at the screen and saying that doesn't look very perpendicular. But that's because this length looks to be longer than this length right there. So it's going to stretch out our graph a little bit. So don't go by graphing to determine whether something's perpendicular. Go by the slope. Okay. But we have to put it through this point here, negative 1, 3. And like I promised, I'd only do this one way this time. This time I'm only going to do point slope form. If you want to do slope intercept form, you can work from there like this or like this, but make sure you use instead the slope 3/2. So this will be y minus 3 equals 3/2 times x plus 1. And that's literally it. I want to make sure that you understand that's an answer and that's valid. These are only different by the slope. Obviously they have a different y-intercept. You can't notice the y-intercept in point slope form though because they don't give you intercept in point slope form, only in slope intercept form, and that makes sense. But you'd notice if you got a slope intercept here, it should be something around 5 point something. Looks like it's going to cross up around 5. So make sure you're aware of that. Okay, given AB at right, find coordinates of the midpoint of AB and label it M. So because there's a graph here, I'm going to go the easy way first and make sure that you recognize, and not easier, but more visually accepted. So to find the midpoint, what I want to do is figure out how far down it goes from A to B, like finding slope, going down 2. This is going over 6. So to find the midpoint, instead let's go half that distance. Like it'd be fine for me to figure out what this distance is and find half of it and go from there, but that doesn't help calculate it unless you know the vertical and horizontal distances as well. So half of negative 2 is negative 1, going down 1, and going over this way, it should meet at a point, but this time you're going over 3. And that's really what you want to figure out. Starting from A, which is at point negative 1, 3, just like last time, B here is at 5, 1. Well, this point here, M, is going to be down 1 from 3. Let's write that over here. M is down 1 from 3. And it's over 3 from negative 1. So I'm taking this point here, I'm going down 1 to get to 2, and going over, I mean, you can see the point right here, 2, 2. But going over 3 from negative 1, that gives you the point 2, 2. Another way of going about this problem is first figuring out what these 2 points are, negative 1, 3, and 5, 1. These are the x values, and these are the y values here. And what you're going to do is find the average of the x values and the average of the y values, and then you will arrive at your answer. So the average of the x values is negative 1 plus 5 all over 2. You add how many entries there are and divide by 2. And then there's 3 plus 1 divided by 2. Both of these are 4 over 2, negative 1 plus 5, and 3 plus 1. And you get 2, 2. Same thing as before. 2 different ways to do it. This way, you know, kind of have to know the formula, but you also just might understand the law of averages there. You'd probably want to do this one if there's no graph. And if there is a graph, hey, I'd go by the counting measure. And so for me, it's makes more sense. You know that you landed on Not that you know you landed on your right answer, but you know if you accidentally, if I made -1 plus 5 equal -6, and I got -6 over 2 equals -3, notice where your midpoint would be. That would be -3, 2. And that makes no sense on a graph. So at least with the graph, you kind of know where you should be at. If you need to use the math afterward, go ahead and check with it. And that looks appropriate. Okay, determine the length of AB. Now, here's also why using the graph is good, because I've already done half my work. If I want to think of this guy as one right triangle, right here, here's the hypotenuse, and here are your two legs, then I've already found the distances of the two legs, and I can use Pythagorean theorem and say a squared plus b squared equals c squared, where a and b are the lengths of your legs, and c is the length of your hypotenuse. Now, it doesn't matter which one you use as a or b, and it doesn't matter if either of them are negative, because when you square the value, it'll become positive anyway. -2 squared is 4, 6 squared is 36, so c squared is 40, so c is the square root of 40. Now, if you're simplifying the radical, that length is 2 root 10. Or, if you were going to take the square root of 40 and actually get a decimal approximation, then it would be 6.32 units. It didn't ask to round to the nearest tenth or anything like that, but let's go round to the nearest hundredth, 6.32 units like that. Either way is acceptable. Now, what if you didn't have the graph? What if you didn't think of it as Pythagorean theorem? What if you only go by memorization and want to use the distance formula? All right, that's fine. Let's go ahead with distance formula. And distance formula still uses x1, x2, y1, y2. So distance formula is the square root of x2 minus x1 quantity squared plus y2 minus y1 quantity squared. But I want you to understand that when you're finding x2 minus x1, you're finding the distance between x2 and x1, which is 6. And the distance between y2, y1, -2, or, 2, really, just like this one. So you're doing the same thing, essentially. You're going to take the square root of this stuff along the way, right? Notice, we're going to get the square root of 4 plus 36, or the square root of 36 plus 4, but we're doing the same stuff there. Now, in one case I use C, in one case I use D. Doesn't matter. We're trying to find the answer. We're trying to find the length of it. And that is the length, square root of 40, or 2 root 10 units, or 6.32 units. Okay, number 8, we have our compass here, and we're going to be doing 3 different types of constructions using a straight edge and compass. We're not using a ruler, so to speak, no measurements involved. We're just going to go ahead and find these 3 things. First one is constructing a line perpendicular to line L, it's right here, through point N. So it's going to go down like that and be perpendicular. So how to do that? First, we have to make a perpendicular bisector, but in order, like something that perpendicularly bisects a part of this segment here, meaning I need to make 2 endpoints, and then I need to make a perpendicular bisector that would go straight through N. And the only way to know how to do that is to get 2 points on the graph that are equidistant to N. The only way to do that is by creating an arc that goes, with the pivot at N, goes through at 2 points. Doesn't matter where they are. In fact, let's do it even a little bit bigger. 2 points that go through here by making an arc. These 2 points here and here are both equidistant from N. I could make an isosceles triangle doing this. I could say this segment is congruent to this segment. This segment doesn't have to be congruent to those other 2. And this would be isosceles. Why does that matter? Well, you just need to know that they're equidistant, because then when you make the perpendicular bisector, it would go through N and right down the middle, and it would be perpendicular. So that's the important part of this. I have my 2 points that I want to use my compass with. So now that I did those 2 points, I need to do another set of arcs that they need to go past the midpoint like that. I don't think will, but they need to go past the midpoint. So I'll stretch this a little bit, and I'd have to make an arc like so. Now, I do not have to bring it all the way up like this. I'll show you why in a moment. But I'll first start with that, because you can use this. And flip this point right here and go ahead and do that. So what you do need are points that intersect, arcs, but you don't need it at the top. The reason why is because you already have a point up here. You don't need a second point. Now, it looks like my drawing, my pivots might not be pinpoint perfect, But if I do draw a line through here, it's supposed to represent the perpendicular bisector. So it's not perfect, but it's supposed to represent the perpendicular bisector of this segment right here. Just that length. And it's also perpendicular to the entire line, and it goes through that point. So again, it began by creating 2 points by starting your pivot on point N to get them equidistant from N, so you can make a perpendicular bisector so that it would go through N. Now, I did not need, I might have to redo the compass stuff though. I did not need that upper bound though for this particular thing. For this one, I only needed ones on the bottom specifically. So all I needed was an intersection there and here. And the reason for that, again, is because I already have a point up above right there. I don't need a second point right here. I already have one. Between this one and this one, we'll make it. So it saves you, what, a couple seconds of time, but at least you still have an understanding through it. Okay, number 8b, construct a line perpendicular to line L through point P. So, and again, the thing about this is that L's a line, it's not a segment, so I can't use endpoints to refer to this stuff. But here, with point P, I could go ahead and make 2 points that are equidistant from P, just like I did for N. To do that, I'm going to place my pivot on P, and I'm going to have some width, doesn't matter what it is, as long as it's on the line, get an arc on one side and on the other side. And when I do, I have now created 2 points that are equidistant to point P. So for me, that creates a segment with this as an endpoint and this as an endpoint. And if I make the perpendicular bisector of this segment, because it bisects this segment right here, and because P is the midpoint of the segment, it'll go through point P automatically. So in order to do that, I'm going to do like I did last time. I'm going to place my pivot on one of the endpoints. I'm going to create, this time I have to create an arc that goes all the way up and down, but I'm going to create an arc. Doesn't matter where it goes, but it needs to go past the midpoint. I have to go up and down on one endpoint and the other endpoint. Whoops, but I need the same width. And I have to draw a line through it, through those 2 points. Let's say that's it, because that looks pretty good. And it's going through point P, and it's perpendicular to point P. And again, it's a perpendicular bisector of this small segment just right here. So I didn't use the entire line, just that one point. Finally, 8c, construct a line parallel to line L through point N. So parallel this time will require me to use something like corresponding angles. Okay, now to make that happen, I'm going to go ahead and make a transversal. Now the transversal can literally go anywhere. I could make it through point P if I wanted to, like through points P and N. I want to go ahead and do that because you have the point. But I could have made it anywhere through the line as long as it goes through point N. Okay, I want to make sure that that's known and understood. Because all you need to make are parallel lines, right? So in making parallel lines, I have to... So basically what's going to happen is there's going to be a line that's going through N like that, but I'm not getting there yet. But when you have parallel lines, you have congruent corresponding angles, or congruent alternate interior angles, or whatever else. Now I've done corresponding angles a lot before, so I'm going to try and do alternate interior angles this time. But in order to do that, I have to recognize that N's a vertex like P's a vertex. So I have to say if alternate interior angles are congruent, then the lines are parallel. So let's construct an angle that's congruent to this angle right here. So in order to do that, I have to make an arc. I'll make it a little bit bigger that goes through both sides. Now I'm going to do alternate interior angles, which means I'm going to be making this angle over here. Let's see. Right here. This one's a little different. Normally I do corresponding, but notice I'm going to say that this angle here is congruent to that angle. Now what I have to do is find the width of this arc going from one point of intersection to the other. Basically what I'm going to do is make this X arc over here on this intersection point And if I draw that intersection right there, the line that goes through N and that intersection point is the line that's parallel to it. Because now I've made congruent alternate interior angles. So there's that final line, and it is now parallel to that line right there. So these are alternate interior angles. I could have done corresponding angles, alternate exterior angles. Normally I do corresponding, but I wanted to give you another example so you see that they all work. Number nine, find the measures of the angles below. Woo! All right, got a few things to work with here. And where do you start, right? That's the big question. Here I know this is 50. I don't know that this angle is congruent to this one. Make no assumption that you know that. But I do know that B plus C is 180. I know D plus E is 180. I know F and G are the same because these lines are parallel. Therefore, corresponding angles are congruent. I know D is equal to C, stuff like that. Here's where you start. A is a right angle, not because it looks like it, but because the theorem that I stated before. When a line is perpendicular to one of two parallel lines, then it's perpendicular to the other. And if this is, or for just another reason, if this is 90 degrees, then this is congruent to it because these are corresponding angles. So A is 90 degrees, has to be, based on the fact these lines are parallel and this is a right angle. If this is 90 and this is a right angle, B and 27 are complementary. So B is 63 degrees. Okay. C and B are a linear pair, as I stated before. So C plus B is 180. Subtract 63. You'll get C equals 117. Okay. C and D are alternate interior angle. Alternate interior angles, so they are congruent. So C equals D, so D also equals 117. You could say D and E are a linear pair, which I stated before, but B and E are also alternate exterior angles, other sides of this transversal through these two parallel lines. So B and E are equal, so E also equals 63 degrees. Okay, F, it's a same side interior angle with D, but these two lines aren't parallel, so that won't help you. What will help is if I know that this is 63, then I need to find out what this guy is right here by saying 50 plus 63 plus this angle are 180. Or you could say that 50 and 63 are non-adjacent interior angles to the exterior angle F. Again, you're looking at an example like this right here. Here's F, here's 63, here's 50. So F is 50 plus 63, which is 113. And G is congruent to F because these two lines are parallel and these are corresponding angles. So G equals 113 degrees as well. There may be other ways to go about it. I'd say that there may not be. I mean, obviously, like I said, you could make D and E a linear pair instead, or you could find this angle first instead. But that's kind of the way that you go through this problem. You got to start with A on that one. Number 10, find the value of the variables. All right, so we have a right triangle as the big guy, a little triangle right here, an X right here. Again, a lot of different ways to go about it. I don't know if I want to save you time or increase time or whatever. Y might be the easiest for most people to determine how to solve for it. Might not be the easiest to solve for. I'll show you how come in a second. 60 plus 55 is 115. So Y is 65. Once you know that Y is 65, you can solve for X because they're a linear pair. So X plus 65 is 180. So X equals 115. Now, notice another way you could have solved for it. X is an exterior angle to this triangle, where 60 and 55 are two remote interior angles. So I could have added 60 and 55 to get 115. Notice, I already got the answer here for X. It's right there. So I didn't need to do that extra work to add 115 to it and then subtract it, supplement from it, and get that value out. But it doesn't matter. Either way, you're still at 115. Now to figure out z, there are two different ways. I could have done this from the very beginning because 55 and 90 are the two angles of the bigger triangle, and z's right here. And in a right triangle, that means your other two angles are complementary. So z plus 55 equals 90 as well. So z equals, what is that, 35? Okay. Another way I could have solved for it is by figuring out this angle measure here first. That's 30 because these two are complementary, so these add to 90. And if you found out x was 115, you could then say that 30 plus 115 plus z is 180. So 145 plus z equals 180, so z equals 35. So kind of multiple ways to go about those problems, but you got x, y, and z all together. Okay, this one right here, you have one unknown variable y and then one unknown variable b all around here, and then one unknown variable z. It looks like you should go by the angle that you first know to then work on the rest here. And now this is irregular, so you can't go by like, oh, they're all the same interior angle measures. No, they're all uniquely different, but we'll go by the interior angle sum to figure this out. To do that, I first need to know what y is. So as a linear pair, this must be 115 degrees. 65 plus 115 is 180. Now when I add up 1, 2, 3, 4, 5 angles right here, this pentagon, this five-sided shape, I will be getting the interior angle sum of 5 minus 2, which is 3, which is 540 degrees. So when I add up all 5 of these angles here, 115, b plus 5, b minus 20, and b minus 40, I'm getting 540 degrees. So let's solve for b now, and then we can solve for z. So there are 1, 2, 3, 4 b's here. 115 plus 5 is 120, minus 20 is 100, minus 40 is 60, or this is a b, not a 6. That equals 540. Subtract 60, 4b equals 480. Divide by 4, b equals 120. So if b is 120 and y is, let's see, equals y, let's solve for z now. If b is 120, this angle measures 100. So z equals 180 minus 100, which is 80. That's really the only way that I would reasonably go about solving this problem. You had to get that interior angle sum to do the rest with the linear pairs. Okay, I think this is the last problem here. Using a straight edge, graph the two lines with the following characteristics on the graph at right. Okay, line P intersecting points -3, 5, that's A, and 1, -1, that's B. So let's go and draw a line through that. So kind of looking like that. And then, oh, that's line P. And then line Q, represented by the equation y equals -3/2 x plus 6. So to do that, this is my y-intercept is 0, 6. I start from there. Now I'm going to have to go down 3 over 2 because it's negative, down 3 over 2, etc. See, it's always better to have more points in a way because now you can, I don't know, you can see better where you're trying to put your line through exactly. Like that seemed to help. Whoops, it did until I let go. So that's line Q. Its x-intercept is C. Its y-intercept is D. So A, B, C, D. Okay, draw line BC. So I have to draw a line that goes through points B and C. It'll be green. So let's go ahead and do the best we can there. Whoops. That's absolutely, oh, that's the best I could have done. There we go. Okay, right there. A lot of instruction. Is it true that measure of angle DCB plus measure of angle ABC equals 180 degrees? Does this plus this equal 180? Justify your answer. So what you're not going to do is you're not going to take your protractor and measure the two. What you want to determine is whether these two same side interior angles are supplementary. In order to do that, you have to figure out, are these two lines parallel? Line AB and line CD, or line P and line Q. Are they parallel? So the real question is P parallel to Q? In order to know, you have to know if they have the same slope. We already know Q's slope. It's -3/2. So what is the slope of P? So in order to do this, because you have the graph, you could literally do a count between points. For instance, from A to B, I go down 1, 2, 3, 4, 5, 6, and over 1, 2, 3, 4. Whoops. So down 6, over 4. That reduces to -3/2. So they're parallel. It's awesome. Another way I could have found this is if I know the 2 points for A and B, which I do, -3, 5, and 1, -1. I'll do y2 minus y1 over x2 minus x1. And that's 6 over -4, which is -3/2, either way. Because these two are the same slope, the lines are parallel. Because the lines are parallel, same side interior angles are supplementary. Because same side interior angles are supplementary, yes, measure of angle DCB plus measure of angle ABC equals 180 degrees. Fiend!